Okay, so a lot of hoo-ha poo-ha there, but basically you already get this, that when you are substituting, so if I'm dividing by x take k, when you substitute that in, you get a remainder. The only difference now is that instead of us saying, oh, we are going to, oh, what happened to my lines? I swear I had lines there. Never mind. Instead of saying blah, 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 I'm dividing p of x, that's a p of x by, let's say, x take 3, and I get a remainder of 4. All of that we can simply say, okay, p of 3 equals 4. If we said p of x, we're dividing by x take 3, and it's a factor, a 0, a root, then what would that imply? P of 3 equals 0. You can do it by dividing, you could do it by synthetic division, you might just sub it in. So that's the concept that we are fooling around with. And you might go, yeah, that didn't seem very good, but let's have a look at some actual questions. Okay, so not a huge fan of going through these examples, but they're quite cute. Use the remainder theorem to find the remainder when this is divided by x plus 2. So all you're doing is you're subbing in wherever x is, replace it with minus 2. And you go, seriously? We did this in year 11. Let's not bother. Well, guess what's going to come? There's going to be some unknowns. And you will have to do that. We're not going to do number 1. It's a bit silly. Without performing division, find the remainder when this is divided by x take 1. So if you could do that, and we're not going to do them all, I'm doing it for a reason. So you could just do it on your calculator. You don't have to even write anything down. But everybody has an answer. You all have an answer. So what I'm asking you to do, we'll just say that again, is find P of 1. So I'm now doing the synthetic division stuff. So you know where these have come from. We add, 1 times 1 is 1. We add, we times, we add. So when you substituted 1 in place of here, did you end up with 1? Yes. So you can see how they're linked. It all works out. That's what it's doing when they sub it in. So you have got a choice now. When there's an unknown, right, you might want to then just do this and sub it in, and you'll get something A equals. You might want to use the division process, right? Especially if you had, and I think we talked about this last time, but I say so much, especially if this thing here was maybe a plus 1, and we said, well, what would a have to be for x take 1 to be a factor? Well, then you'd say, well, a has to be minus 1. Does that make sense? I'm going to get rid of that in case someone didn't listen to the video and they just looked at my notes and they go, where did that a plus 4 come from? Anyway, so let's get stuck in. So question 3, what will you do? And you're not actually going to do it, we'll just tell me what you would do. Psst, you've done this. I know you've done this. They haven't done this. Have you done this? Oh, well then you should do this. Right, so divided by x take 2. You're very quiet. Am I going too crazy? Or you understand what I'm doing? Or you don't? It's one or the other, really. Thank you. Nods. Look, if you want to write this down, by all means you can, but I'm thinking it would be a waste of your energy. So divided by x take 2, that means we're going to go p of 2, and the remainder is 7. So we say equals 7. And then just sub it. So 2 cubed is 8, or shall I write 2 cubed? Thank you. Minus 2 times 2 is minus 4 plus a equals 7. And I think we're all pretty confident of saying that a then must be 3. It will build up. Fear not if you want that challenge. Okay? So we just want to get into the good stuff and not waste our time here. So that would be the same thing. Wherever x is, replace it with -1. Just be careful. When you cube a negative, you get a negative answer, and so on and so forth. All right, so now let's do 4 together. So please put your heading, exercise, whatever that is. Let's have a look. Oh, too quick. 2E. S'il vous plaît. No? Did I jump?
Yeah.
Oh, jeez. My board jumps.
Right there. Oh, even up.
This is 2E?
Yeah.
Yeah.
A bit down.
I thought you said it wasn't 2E. Okay. You're killing me. 2E, question 4. Let's hit it. I'm being useful. We've got this polynomial. It's divided by x take 1 and the remainder is 4. So as soon as we see that, we are going, right, p of 1 equals 4. We read on. We then notice that when it's divided by x plus 2, the remainder is 16. So then we go, okay, that means p of minus 2, that's right, equals 16. Huzzah? And now we're going to sub it in. You can probably predict what we're going to get. Right, we're going to get something a is b equals, and then another one over there, and we should be able to solve simultaneously. So I'll try and do it quietly. You do it without looking at me if you want. 1 squared is 1. 1 times a is a plus b equals 4. 1 plus 2 is 3. We're tidying up, so we end up with 3 plus a plus b equals 4. So I'm going to whack the 3 on the other side and I get 1. I'm going to do the same thing on the right hand side. We have to do one test this year that has no calculator in it, and that's probably going to be the induction question. So it's up to you. When we have this situation, you want to use your calculator to solve simultaneous equations. Personally, for me, going to my calculator is probably going to be longer than just solving it, because you can see the b's have the same coefficient. All right, so I would then put this under, so I've got 2a plus b equals 16, and in order to eliminate the b's, we subtract. A take 2 is 3a, b take b, no b. 1 take 16 is minus 15, and huzzah, a is minus 5. To get your b value, we pop it back in here, or there, doesn't matter. This is clearly the easiest one. If a is minus 5, then b must be socks. And we have found the constants, et and bet. With 5, just be aware with question after that, we have just been dividing by linear. Okay, point this out with the example. I hope you don't just skip them. You can, I think they're quite cute. Read them, as I said. When you're now dividing by quadratic, things change a little bit. Because when you think about your division-y stuff that you did, when you divided by a quadratic, what was your remainder? What form did it take? Like, look back at some of those division ones, long divisions that you did. When you divided by the quadratic, what was your remainder? I can find it. It was linear, right? When you divided by a linear, your remainder was a constant. Guess what? What would happen if I divided by a cubic? What could my remainder be? Quadratic. You drop one degree. Does that make sense? So this thing, I think you should put this in your notes, that when you are dividing by a quad, your remainder can be linear. You can put it in whatever words that you want, but that's the bit of the catch. Question 6 is nice because they already put it in this form for you. They tell you that your remainder is linear. But when it comes to question 7, right, oops, better adjust that. X plus 1, the remainder is minus 8. And it's divided by z take 3, the remainder is 4. So you're actually dividing by double whammy there. The first thing we actually have to write is pz is going to be qz. I'm dividing by, and do you get when I'm saying I'm dividing by, it's downstairs when I times it up. So you're dividing by the z plus 1, you're dividing by the z take 3, and your remainder now is ax plus b. AZ! Thank you. Simity Sam is AZ plus b. And so now when we have this divided by z plus 1, you're going to go p of minus 1 equals minus 8. And the other one will be p of 3 equals 4. If you didn't have this and you just had r, you don't have those unknowns to find, okay? So that's your little tip with that. So good luck, keep on going, and now I'll be quiet and you do your thing. Hello. I don't know where I left off with the recording or where I paused, but we just had a question about number 6 and I got carried away and didn't record. So we're just saying we're reading what is up there and we're writing it in our remainder theorem situation. So we've got p of z as being divided by this quadratic. It means you get this answer and we're left with a remainder. And we actually went back and we looked at the long division stuff that we did. If you're having a bit of trouble about why this is, look back at your long division and you'll see, yeah, it makes sense. And in this case, our remainder, they've told us, is 4z take 7. So that's how we get that stage. If you didn't recognise that this thing here factorised to be the two answers that they're asking you to suss, it doesn't matter because you would still, when you pop in, z is 1 here, so p of 1, everything becomes 0, okay? So yes, you don't know what q of 1 is. That's minus 1, but then 1 take 1 is 0. So that whole thing just cancels out. Replace z with 1 here, bang, you get your answer. The same thing will happen when you do part B. And we said that, okay, they wouldn't ask you what happens if it's dividing by z take 3, because then you'd need to know what q of 3 is. If they did, you'd have to leave it as q of 3 times blah, 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 blah. Okay? And then, what did we do with 7? Oops, don't know what happened there. Well, I do. I just didn't lift it all up. So hopefully you had a go class with 7, and we've got when p of z is divided by z plus 1, the remainder is minus 8, and then it's divided by z take 3, it's 4. Find the remainder when it's divided by. Now, as soon as you see that this is being divided by a quad, then we do the same thing. We're going to have p of z divided by the quad equals q of z plus a linear factor over that quad, and I've just gone straight to times 3 by the quadratic. Okay, this is my quad here. So digest that first. And this time you can see same thing is going to happen, p of minus 1. So when you put it in here, minus 1 plus 1, that will all cancel out. So that whole thing there, gonski. However, so 8 equals, we will now have minus a plus b. Uh-oh, 2 unknowns. That's all right. You know what's coming, don't you? You got another, yeah, you're going to have simultaneous, baby. Got this, right? Can't go any further. Over here, okay, 4 will equal, now wherever this is saying, go to your polynomial and wherever z is, replace it with 3. But once again, you go, uh-oh, q of 3, I don't know what that is. 3 plus 1 is 4. Oh, sweet, because 3 take 3 is 0. So once again, that whole schmozzle disappears. 3 times a is 3a. and then we've got plus b. So now we've got two equations with two unknowns, and we should be able to swiftly and confidently solve. I would do it by eliminating the b's. So I'm going to pop that underneath. 8 equals minus a plus b. And I'll just stop a bit. We're going to subtract 4 take 8 is minus 4. Just be careful here. 3 take becomes a plus, so I get 4a. The b's disappear, so therefore a is minus 1. And of course, slap it back in to find b. 8 equals minus 1, so that's 1, so b must be 7. But we're now moving on. We have a look. Find k, given that x take 2 is a factor. Now, I could scroll back up to the stuff we did with equating coefficients, and I would see a very similar question. But what they're asking you to do now is, I mean, they're not technically saying use synthetic division, but that is now an option for us. So you can, if it's a factor, we can sub it in, and we can say, right, when we replace it, it has to equal 0, so bang, you can find k. As we did before, you can do synthetic division, and you can pop it in. You could have done this blah, blah, equals bracket x take 2, and then you'd have to have another quadratic. So you've actually got 3 ways of solving these problems now. You could, so when it's saying, sorry, the question was, what was the other way? So you've got the synthetic, you've got just subbing back in, and you've got the equating coefficient. So we could go equals bracket x take 2, close bracket, and then you know, you'd have the a, you'd have the c, you'd have to work out the b. That's probably the longer winded one. You go, why did we do that? Well, sometimes it's cute if it's given in that form, and it just helps our algebra and understand the whole expanding situation. So we are now going to carry on, and what you will find is sometimes the synthetic works, sometimes it's just better to sub. So for 2f, blah, 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 has a factor, I would straight away just go p of minus 2 equals 0 and sub in. You'll be left with k equals 0. Do we need to do that? I think let's just save ourselves a little bit of effort. So put a little heading, exercise 2F. What exercise? Was we up to E or F? F. Yeah, baby. I think we have to do G. Who knows? All right. Find constants A and B, given that has factors. So method, numero uno. And I'm not saying numero uno because it's the best. It's just the first one that popped into my head. So the first one we could do P of 1 equals. The key word here is it's a factor.
0.
P of 1 equals 0 and P of minus 5 equals 0. You're going to slap them in there. You're going to end up with something A plus B equals something A plus B equals solve simultaneously. Agreed? Ashley, you might go, I don't care for that. I was really a fan of, and I'm going to get a t-shirt made, of the fact that I really like to do it by equating coefficients. Don't worry about dressing up in glitter for Swifty. We'll make t-shirts of equating coefficients, maths. Oh my God, I have to go and find my little pot. Have we got them back? Or are they still in the art room? The pots you planted. Oh, that's a recording. Now, remember, it would be x take 1 times x plus 5, but I'm just going to expand that to make my life easier. Now, x squared times what gives me 2x cubed? That has to be a 2x. Minus 5 times what gives me plus 5? That has to be a minus 5. And now you could equate coefficients to find the a and the b. Yeah? We're happy with that. What's the third way? Synthetic, I guess a fourth way could be long division, but we don't want that. Synthetic division could be, and you go, how are you meant to do that? Well, I'm glad you asked. And by the by, I reckon this would be the best version for this question. Just in case you guys are thinking, she's nuts. Okay, so we divide, we go 1 here, 0, 2, 2, a plus 2, a plus, oops, there's probably a reason why you shouldn't do it this way. And then a plus b plus 2, so, and that has to equal 0 because it's a factor. And then we're going to go again. We're now going to go minus 5, 0, 2, and so on. And when we get here, that thing has to equal 0. I want you to do it this first way and then have a look at what we had here. I'll finish that and you'll see, I think, something freaky.